Not so much that you're falling asleep in your jammies, but you know, relaxing a little bit is good. Our objective, we are going to write an equation of a line given its slope and a point on a line. We started this on Friday, and we did not get real far. Let's go back to this guy. Oh, which one is this? 19? Let's do this.
Yeah.
One of the things that we do each year is we talk about the results of the MCAs and the ACTs, and we always get together and say, okay, now, what about this year? You know, what can we do to bring the MCAs up? Not that our MCAs are fabulous. You know, we're number one of the top 10, the top 10 biggest districts in the state. But what we have to do is get more practice at the what's wrong with this problems. The ones where there's something wrong with it, and we have to figure out what on earth it is that is wrong with it. So I want you to take a look at that, and take a look at your notes, and see if you can figure out what happened there. Why is that not what we have in the notes? Oh, the negative slope? Yeah, so we've got a -7 in the back here. Because the slope of this one would be 7 minus 0, which is 7, and 0 minus a -5. 0 minus a -5, that's a +5. So the slope should have been positive. And they put these on the MCAs and the ACTs all the time. And I always think, why do they do that? This is multiple choice. But it gives you a chance to go through and look and say, okay, I did this, they did that, where's the error? And find it. And that's what they want you to notice, is when they're made, what did they do wrong? They calculated the slope wrong. That's what happened there. So I'm going to try to do at least one of those a week this year as we're going through it, and just say, okay, I just did this. What's wrong with it? And let you guys find that mistake and tell me how to correct it. So now we're not going to do the little discussy thing there. Today we're going to talk about parallel lines and perpendicular lines. Sounds exciting. Oh, did we fill in boxes? You guys were ahead of the other hour. Okay, so parallel lines, their slopes are the same. Slopes for perpendicular are opposites and reciprocals. Now, this says, what is the equation of each line, and then simplify your final answers to slope-intercept form. We talked about on Friday about how every line has exactly one slope-intercept form. And so in the back of the book, they don't want to put every equation for every line because there's an infinite amount of them. So what they'll usually do is tell us to put that answer in slope-intercept form. Now this one says I'm supposed to write the equation for a line parallel to that through that. Well, that's a point. I have one formula that uses points. That's the point slope formula. But I need a slope. Do I have a slope? Mx plus b. Yeah, you are absolutely right, Abby. The slope is 5. All right. So now I start thinking, okay, if I have a slope and I have a point, I can put this in point slope formula. It is a parallel slope, and it is 5. This one too? Oh, the other class was well behind you. All right, well, real quick, because it's going to drive me nuts. I would want to see the whole thing. Did that. Well, how about this one? We did? You're aces. So let's flip it. Now comes trouble. Because this is not y equals mx plus b. I mean, these are not tough to do if you have the slope sitting there staring at you. So what is the equation of each line? Simplify your final answer to slope-intercept form. We want the line parallel to that one through that point. But I can't tell what the slope is until it says y equals mx plus b. So what do I do to this to make it y equals mx plus b? Subtract 4x. X on the other side. Then what? Divide by 2. Y equals negative 2x plus 7 halves. Now, if the plus 7 halves is driving you bonkers, we don't care about the plus 7 halves. We care about the slope. So what's the slope of this line? So what's the slope of the line parallel to that line? Negative 2. So we're going to use the slope of negative 2, and we're going to use this nice little point 4, negative 2. And we're going to write an equation for y. Well, since we already went through so much of this, can you tell me what would be on the left side of my point slope form? Equals beautiful. But that's not in slope intercept form, right? Distribute the negative 2. Gotta be careful. We've got negatives in there. So negative 2x plus 8. Then subtract 2. Y equals negative 2x plus 6. Done? Yeah, that's slope intercept form. You know? So a little more work because this is actually called standard form, ax plus by equals c. And what we had to do was get it into slope intercept form so we could tell what the slope was. Once we had that, hey, we've done that lots. That's not a problem over there. The green is not a problem. So now what? Ooh, the willies was perpendicular. All right. Well, the line perpendicular to y equals 2/3 x minus 1 through the point 0, 6. I have a point. I need a slope. You need a slope. So far, this line has a slope of 2/3. Are we supposed to use 2/3 for perpendicular? So we need the slope of the perpendicular. What would that be? Negative 3/2. Good. I heard more than one person say that. Excellent. And then remember, I hope we talked about this on Friday, at least put a line through that so that you don't accidentally use it. Unfortunately, that happens all the time. People just, oh, I had the slope up there, it's 2/3, and they just keep going and forget it's perpendicular, don't use that one. All right, so slope, point slope form would look like what? Y minus 6 equals negative 3/2. Just x, because it's a 0. Good. Yeah, let's skip that step if we can get away with it. Well, that looks super close. What do we have to do? That's it. Add 6 to both sides. Y equals negative 3/2 x plus 6. Bam. Right? But perpendicular, okay, parallel is the exact same thing. That's the M. You know. But for perpendicular, whatever they have for M, we have to flip it over, take the reciprocal, and then slap another negative in front of it. So opposite and reciprocal, or negative and reciprocal. Some folks will say that. So perpendicular, opposite, and reciprocal. We can remember that. We're golden. All right. We have more pages because we need to talk about that standard form. Standard form doesn't seem too bad. Standard form of a linear equation: ax plus by equals c. Okay, so not y equals mx plus b. Ax plus by equals c. So we've got the x's and y's on the same side, and then we've got a number over on the right-hand side. Now, here's where things get a little weird. A, b, and c are real numbers. Scratch this off. They are integers, not usually integers. They are integers. That's one thing that any professor you'll ever have will agree on, is that you cannot have fractions and you cannot have decimals when you put something in standard form. Now, there are other things that you might not have them agree on, and one would be some professors insist that that first A term be positive. You have to have that be positive. And it's not a bad habit to get into. but they all agree they have to be integers. No fractions, no decimals. And A and B are not both 0, because if they are, then things get very weird. Because if we have 2x plus 3y equals 7, and we put a 0 in for both x and y, it's going to say 0 equals 7, and it's not going to have any solutions, which is what we want. We want a line. So A and B cannot both be 0. So this just says, hey, let's figure out how you rewrite this equation below so it's in standard form using integer coefficients. First thing I see is there's a fraction there. That is a huge no. We can't do fractions. What would we do to this if we were trying to solve it and it had that as fractions? Well, then we're still going to have decimals, and fractions and decimals are out. We can't have them. Let's multiply by the LCD. What is the least common denominator for this? If you're looking at that and saying Cedar Home, they don't have denominators. Yes, they do. What's the LCD for 1, 5, and 1? 5. We're going to multiply every single term by 5, and there are 3 of them. This gets a 5, this gets a 5, and this gets a 5. So now we'll have 5y equals, well, those two 5s are going to cancel out. We'll get 2x minus 15. No more fractions. Just multiply by the LCD. Now we're super duper close. All we have to do is move the x over on the side of the y and put it in front. So, what should we do? How do we move this over here? Subtract it. Subtract 2x. Minus 2x plus 5y equals negative 15. Now, like I said, every once in a while you'll have a professor that says, oh, that is just awful because your first term is a negative. Well, if that's the case, all you have to do is change all the signs and it will be equivalent. And that's because what we're really doing is multiplying it all by negative 1, and that's equivalent. Now, you could have stopped here for me. I'm going to give you full points for that right there. But there is a reasoning. This is a little bit easier to work with when A is not negative. And so that's why some of them get really picky. Let's say positive first leading coefficients on that. So now, oh, that looks harder. That's a decimal. Okay, write this down and think about it. I can't leave decimals and fractions. These are actually super easy. If you don't leave them off as nonsense and actually use the right math term for it, what you don't want to do is read this off as 9.1x. What is this? 9 and 1/10. You just found that you have to multiply all of these by 10. And you always take the smaller of the decimal places. So if the 3.6 had been 0.36 and it were hundredths, then we would multiply everything by 100 to get rid of the decimals. But these 10 multiplied by 10 and 100 and 1,000, that's pretty easy stuff. So 10y equals 91x plus 36, because you just move the decimal over one spot. That's what you do when you multiply by 10. Super close. What do we have to do to get the x and the y on one side? That's it. And of course, they're not like terms over here, so we still keep them separate. Negative 91x plus 10y equals 36. You can't put x's with y's. Stay separate. And there it is. Now, you could argue, is that really simpler than y equals 9.1x plus 3.6? I mean, is that simplifying? We're not trying to simplify. We're trying to put this in standard form. And so each form is unique and it does different things. We just want to know, how do I get this in this different form? And then we stop. Okay? So it's not necessarily simplified. It's just different. Here is why I love standard form. Graph the equation by first finding the x and y intercepts. You know, there are two types of graphs that you can do like that. And the first one is y equals mx plus b. This is the other one, and I love this one. Because if we are going to find this by finding the x and y intercepts, that means the coordinates of our 2 points will be 0 something and something 0. Because any point on the x-axis is something 0. And anything on the y-axis is 0 something. Now why do I like that? Because you don't need a calculator to do this. It's a little something I call the thumb method. I take my thumb and I put it over my 0. And I realize, well, my 0 is in the x position. What's anything times 0? So I can just cover up the 4 and the x with my thumb, because that's 0. And I'll see 3 times something is 12. What's that something? 4. I have a point on my graph. I grab my trusty thumb. I come down here and say, hey, that's the y position. What's anything times 0? Cover it up. 4 times something is 12. We just found 2 points on the line. We're graphing. Bam! Quick graph. Obviously, it goes faster if you don't have to talk through it. But just remember, if it's going to be 0, that term is gone because it's 0. That's what I use my thumb to do, is to cover that up and say, hey, if this is 0, now this is 0. Totally gone. That's an easy little math thing to do. Now, some of you might say, okay, but what if I get something goofy? You know, what if it's not 3 times 4 equals 12? What if it's 2y equals 17? Big deal. Bring the 2 over and divide by it and say 17 halves. Before long, you realize, oh, that's 8 1/2. I'll just graph it at 8 1/2. You know, whether it's a fraction or not, it's not going to be a problem graphing it. You might have to write something down every once in a while for one like that. But most of them we'll be able to do in our noggin and have a quick graph. So this one says we have 2x minus 4y equals 8. And right away, I think standard form, thumb method, old pal thumb. 0 something, something 0. So that's where you graph on the x and y axis. X's are gone. Negative 4 times something is 8. What's the something? Negative 2. Y's are 0. Y's are gone. 2 times something is 8. What is it? 2 times something is 8. We graph. 0, negative 2. 1, 2, 3, 4, 0. Quick graphs. Love it. You know, almost takes more time to write this down than that. It really does. So we can figure out how to get those quick graphs in standard form and in slope-intercept form. Sometimes people get kind of stuck like a broken record, you know. The needle just sits there and wobbles all over the place. Because you like y equals mx plus b and you want to use it all the time. But some other methods are just as fast if you know what you're doing. So, word problem time. Scary. The office manager of a small office ordered 140 packs of printer paper. Based on average daily use, she knows that the paper will last about 80 days. What graph represents the situation? Okay, that's going too far already. Because here's what I have to figure out. Everything that we've been doing recently gave us 2 points. So if there's going to be 2 points, there have to be 2 different labels in this problem somewhere to say, hey, use this for the x and use that for the y. So I'm going back up to that and I'm just finding the labels. 140 what? Packs of paper. How about 80 what? Now, what she cares about is how many days does it take for those packs of paper to be gone? So days are x, packs of paper are y. So she goes out to the truck. She signs for it. Stuff's not even in the office yet. So 1 day hasn't even passed. 0 days, she's got 140 packs of paper before anybody's touched it. And then 80 days later, how much is left? Yeah, she runs out. Because it says she knows the paper lasts about 80 days. Whoa. Those are the points we need to graph it. But our little graph is 20 by 20. So, let's see. If we go 10, if we go by 5s down here and label every other one, that should work pretty good. Split 20 ways would be going by 7. seconds. So maybe I'll go by tens. So 10, 20, 40, 60, 80. Oops, 20 zeros. 100, 120, 140, 160, 180. Probably better throw some labels on there so people know what on earth we're doing. Our X's were days, and our Y's were packs of paper. Now, if we want to be super fancy, we give it some kind of title. Office use of paper. And that's what all of this is about. Office use of paper. And that took longer than graphing and finding our 2 points because we just need to go 0, 140, and 80, 0. So now, she's noticed that people seem to be using a lot of paper because there was a big project that came up and they're all printing stuff out. And it's about 40 days since she last ordered paper. She could go over to this little graph and say, all right, I'm going to go check right by the printer in there because I should have about 70 packs of paper in there. If I don't have 70 packs of paper in there and I see there's only 50, I better order before the 80 days is up. I got to get this paper in here so they can use this stuff. What happens with places like this is if they run out, the place that they normally order from is really cheap. So if they run out of paper and she's got to go over to Office Max, my gosh, have you seen how much they charge for paper over at Office Max when it's not on sale? That's going to cost them a lot of money. So an office manager is responsible for making sure that those supplies get done cheaply. You know, they're always looking for the sales. Where can I get this stuff? Who do we have for a supplier? So we want to make sure that she can use that. And this says, what is an equation of a line in standard form? Well, that's not a big deal. We have 2 points right here. 0, 140, and 80, 0. I think that's a pretty good starting place for writing an equation for a line. What should we do with those? Slope, intercept, and point slope. Think about the names. What does each one of those require? Slope. Gotta find it. So we'll have 140 minus 0 is 140, and 0 minus 80 is negative 80. Well, they're both divisible by 10, so let's take it down to negative 14/8. We make it even smaller. Why is our slope negative? Well, why is it negative though? What in our problem would tell us that our slope should be negative? As they're using the paper, there's less paper, right? Yeah, that's what this is doing. It's saying losing the paper because they're using it. Now, I don't know. Both of those, I guess, are equally okay for writing this thing. I'm going to go with this one. Y minus 0 equals negative 7/4 times x minus 8. They're both kind of nice because they have the zeros in there. So y equals negative 7/4 x, and then we need to figure out plus 80 times 7/4. Slap a 1 under there. Do a little cross reducing. How many times does 4 go into 80? So 7 times 20, 140. There was an easier way to know that before we did that. What did this start with? Day 0. How many packs of paper? Exactly. Once we had the slope, we could have just used y equals mx plus b. We wouldn't have had to use point slope. But this way, we're totally safe. You know, if you're ever unsure which one you should use, go safe and use point slope. Now this one says, now that you have that fabulous little equation, how many packs of printer paper should the manager expect to have after 30 days? Well, they're saying don't go back to your graph. Now you have an equation. Plot a 30 in for x and see what you get. Well, I have to have this handy dandy calculator right here. had a -7/4. And we're supposed to take that times 30. Oh, I'll do the 0 because the screen is in the way. There we go. And add 140. Or was it subtract 140? Add 140. All day I've been fighting that thing. 87.5 packs of paper. So that's what should be there. If she goes in and sees there's only 20, oh, she better place an order really quick. Gotta see. We get our cheapest supplies in here, so we don't have to buy expensive stuff. The thing that's always funny to me about this is you go to Wendy's and they say they're out of baked potatoes. There's a Cub in Rogers. Not even a half mile. Why won't they go get those potatoes? Because they get them so cheap that if they go to the Cub, it's going to eat into their profits because Cub is more expensive. And it's just one of those things they do. They're going to keep their costs down. But it does kind of bother me because I'm like, okay, your costs are increased a little bit versus you have a customer who will never come back again because you're out of baked potatoes. You know, it's one of those things. But oh, here we go. Taxi rides. The cost of a taxi ride depends on the distance traveled. Oh yeah, that's how taxis work. They've got a little meter, and it says you paid $8.50 for a 3-mile ride, while your friend paid $18.50 for an 8-mile ride. What graph models the situation? Well, I see 2 labels up there. What are the 2 labels? Cost and distance. Okay, which of those do you have some control over? The distance, yeah. So we would want distance, comma, money for our ordered pairs. So what's the first ordered pair that we see up there? And then there's another one later on for your friend. What's that one? Yep. Oops. My hand is not keeping up with my brain. There it is, 1850. What graph models the situation? Oh, we gotta get these points on here. So let's see. For the x's, we have 3 and 8. Oh, well, we could probably spread this out a little bit. And every 2 little blocks. Go by 1. And our x was distance in miles. 1850. Well, we've got 20 spaces. I mean, obviously that'll cover 1850. So if I just don't write in each one, otherwise you won't be able to see it. But still go up by $1 for each little block. And then that one is money. Now we graph our 2 points. 3, 850. And 8, 1850. Should that go for 0, 0? If you don't get in the cab and you haven't gotten anywhere, are you going to pay? So 0, 0 should make sense. I mean, if you're not going any miles, you're not getting in the cab, then nothing's happening. You know, you're not going to have to pay that fee because the meter won't run. You haven't gone anywhere. So, and this one, label at the top, I suppose we could put something like taxi cost. Then if people didn't see the word problem that comes with it, they'd know what we're doing. Does that make sense? Well, let's do the same stuff with this one we did with the last one. It says, what is an equation for the line? Ooh, I've got my points. 3, 850. And 8, make some of you a little nervous when I tell you I want you to find me the slope, but these are really nice numbers. Find me the slope. Don't be scared of them. Change in y, over change in x. Figure it out. Chicken wing and elbow partner. It really is a very nice number. All right, we have some serious overthinkers in here, so let's fix your overthinking. What's $18.50 minus $8.50? 10 smackers. What's 8 minus 3? 5. What's 10 divided by 5? 2. Wow, some people were making this hard. This is 2. 2. That's all it is. 2. Well, do you have a favorite out of those two for brightness? Smaller ones? Yeah, I'm with you. Y minus $8. Well, I'm just going to put 8.5. 8.5 equals 2 times x minus 3. Alrighty, so we'll have y minus 8.5 equals 2x minus 6. Huh. Well, I probably better add 850. Y equals 2x plus 850 minus $6. 250, but I'm going to put 2.5. Now here's why. I got to go back to the other one too. I didn't read the instructions. What form is this supposed to be? Yeah, so we're not done yet. We're close. We're not done yet. First problem. It has a decimal in it. What do we do? Times 10. That's a tenth. 10, a 10, and a 10. So 10y equals 20x plus 25. How do we get that to the standard form? Subtract 20x. That will say negative 20x plus 10y equals 25. Which, like I said, some professor will say, oh, it's a negative in the front. Oh yeah, you can multiply this one by 2. Most of the time we just go with the decimal position, but it's equivalent. It will work. Now, here's the whole reason that I didn't do the standard form before, because of the follow-up question. We're not going to put what would happen in a 10-mile ride into the green. We're going to put that in the red, because that's what that formula is built for. So y equals 2 times 10 plus 250. How much are you paying for that $10? That's what it is. All right, so we do have to go back to the office manager one because I didn't follow directions. You understand? Right down here. So right now, it looks like that. Y equals negative 7/4 x plus 140. So I get rid of the fraction. Multiply the whole thing by 4. Needs a 4 here. Needs a 4 here. And needs a 4 here. Ooh, I've got too many parentheses. So we have 4y equals negative 7x, 140 times 4, 0, 6, 1, 5, 60. And we're super duper close. What do we do to get it to standard form? Right here. Add 7x. 7x plus 4y equals 560. I had to squish that in there. 7x plus 4y equals 560. Now we followed all the instructions. So some formulas are better depending on what it is you want to find. Like with this especially, putting 30 into this blue one would require a lot more work than just going up to the black equation and putting 30 in and figuring it out. Grabbing a calculator for that. And it's the same thing with our problem involving the taxi cab. It would be really, really silly to use the standard form equation and put a 10 in here for x, because then you've got to move things over and divide. That's 2 steps versus putting the 10 in this one. 2 times 10 is 20. 20 plus 250 is 2250. So you want to pick the best equation for the job. What are you doing? What would make that simpler and faster? So our objective today was really generic. It was write an equation of a line given its slope at a point on a line. We did that all day, from parallel to perpendicular to the word problems that we went through to standard form. All of those things are about writing equations for lines. So 4, 3, 2, 1, 0 me on where you feel you're at with all of the stuff we did today. And there's quite a few different methods to keep track of. Those are pretty good numbers though. Good, 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 good. All right, well, then you're ready for some good old-fashioned homework. Woohoo! Yay, see you, give us some homework. We're ready. I'll go wild. There it is. This morning I counted before I gave up because people were just asking when you need graph paper. If you like graph paper, you should be able to do this one with like 1 sheet because I think there are about 8 different one-rated graph. Standard one. Again, not going to make you take that. Some people are worried if they have graph paper, they're going to lose it because it's not in their notebook, so they'd rather make the little cartoon board things on their paper. But it's always available. Tin bins up there. Feel free. Help yourself. The work time today was good trash. You probably get about 5 of those done before you went out. Watch your eyes. Ugh.